Good day, everybody. How are you all? Today, we are going to talk about hypothesis test using the confidence interval method. So I'll share my computer screen with you. Says the weight of a certain kind of bat is normally distributed with a mean of 1.9 grams. A researcher believes that the mean weight of these bats is different from 1.9 grams. The weights of a sample of 10 bats of this kind is given below. Use confidence interval method to test the claim at 10% level of significance. We have 10 data points. So the first thing we will do is use TI-84 to solve this problem. Solution. Use TI-84 to solve this problem. Okay. First step is clear the memories of the calculator. Memories of the calculator. So for that, we will press the second button, then the plus button. Where is the plus button? It's on the bottom right corner on top of the enter button. Second plus and then select number 4. So put the calculator on, press the second button on the top left, then plus on top of enter on the bottom right corner, then select number 4. When we do that, we get clear all list on our calculator screen. Again, press enter and you will see done on the calculator screen. What does it mean? Means memories have been cleared. Have been cleared. Okay. The next step is press the stat button. Then select number 1 and enter. Stat button on the second row, then select number 1 and enter data in L1. So your cursor or the black rectangle should be sitting on the first line in L1, where you are going to enter the weights data. So the first data point is 1.9. Next data point is 2.24. Next one is 2.13. Next one is 2. Next one is 1.94. Next one is 1.96. Next one is 1.79. Next one is 2.18. Next one is 1.81. Next one is 2.3. Okay, so once you have entered the data in L1, what is the next step? After entering the data in L1, what do we do? Next step is press the stat button, stat, okay. Then highlight test on the top row. Highlight tests by moving the cursor by the right cursor key on top of test, okay. And select number 1. Okay, so press number 1. No, I'm wrong. Sorry. So stat, then I should be on the calc. So let me erase all this. This one I can erase. I will highlight calc on the top row, not test. Calc on the top row. Okay. and then select number 1, okay, which is one var stats. So we have one var stands for variable stats. Why one variable? Because we are working with only weights. Okay. So my first line is list. It's already L1 there. Then frequency list. Keep that empty. So on the right of the colon in the second line, it should be empty. If there is something, hit the clear button, which is in the third row of calculator's keys, and clear anything after frequency list. Okay. And then you go down to calculate, means move the cursor on calculate and hit enter. Enter. Okay. So the mean, sample mean is X bar is equal to 2.025. Sample standard deviation Sx is equal to 0.1783. Okay. And sample size, we all know, is n equal to 10. Okay. So they have asked us to use a 10% level of significance. So if I create some space for myself, given level of significance, which is alpha, is 0.10. 10% in decimal is 0.10. So level of confidence, which is complement of level of significance, is C, is equal to 1 minus alpha, is 1 minus 0.1, which is 0.9. Okay. So if I draw the T diagram, it's like a bell-shaped normal distribution, little bit wider. At the center on the horizontal axis, T is equal to 0. Now T curves depend on degrees of freedom. df is equal to degree of freedom. Here df is equal to n minus 1. 10 minus 1 is equal to 9. Okay. Now level of confidence is 0.9. This is your C is equal to 0.9. Okay. So the center area is where most probably the population parameter, in this case population weight, will fall. And the two tails are the least likely region where the population parameter will fall. That is, most probably the population parameter or population weight will fall in the center region. So area of two tails is equal to 1 minus 0.9 is equal to 0.1, which is same as level of significance alpha. So because of symmetry, this is T is equal to 0 in the center, this point. Because of symmetry in T distribution, area in the left tail is equal to area in the right tail is equal to right tail is equal to alpha by 2. So this area is alpha over 2, which is 0.5 over 2. 0.5 over 2. Okay. Sorry, 0.1 over 2. So let me correct that. So area of each tail is alpha by 2. Kali does this. So area of each tail, area is equal to alpha is 0.1 because level of significance is 0.1. So 0.1 divided by 2 is 0.05. So this area is 0.05 in the right tail, and in the left tail also area is 0.05. So we need to find out these critical values, these two critical values. Okay. So this is T alpha by 2 with 9 degrees of freedom, because our degrees of freedom is n minus 1. Okay. So degrees of freedom is n minus 1 is 10 minus 1 is equal to 9. Similarly, this particular value of is minus T alpha by 2 with 9 degrees of freedom. Okay. They're the same because they're mirror images. Now we have to use our calculator to find this T alpha by 2. Okay. Let me create some space. So T alpha by 2 with 9 degrees of freedom, 9 is your DF, is the critical value of T, which separates the central area under the T curve, where most probably the population parameter in this case, population mean weight will fall, mean weight. So it separates the most probable region, okay, where population parameter will fall from the least probable region. Where population parameter, because the population parameter will most probably not fall in the two tails, from the least probable region where the population mean will not fall. Mean will not fall. So how to find this T alpha by 2 with 9 degrees of freedom using TI 84? Using TI 84, okay, we press the second key, then the VARS key, VARS, in the third row. So second key, then VARS key, then scroll down to number 4. Scroll down with the down arrow key to number 4, which is in T. Okay, and hit enter. Okay, now it asks for area. Area in the left tail is 0.025, half of alpha. Sorry, 0.05. My mistake, alpha by 2 is 0.05. It's 0.1 divided by 2 is 0.05. not 0.25. So 0. So this is the area in the left tail. Alpha by 2 is 0.05. So type 0.05. Next line is degrees of freedom, df. Type 9. 10 minus 1 is 9. Then go to paste and hit enter and enter. Enter and enter. Okay. Enter and enter. And the T critical value minus T alpha by 2 with 9 degrees of freedom is equal to minus 1.833. By symmetry, because what happens on the left half of the curve happens on the right half of the curve, T alpha by 2 is same number with a positive sign, 1.833. We need these critical values to calculate the 90% confidence interval. Okay, let me create some space. Okay. So formula for 90% confidence interval. Confidence interval for the population mean weight here. Population mean weight. And that is X bar plus minus T alpha by 2 with, in this case, 9 degrees of freedom multiplied by S over square root of N. This term S over square root of N is the standard error. Standard error or standard deviation of the sampling distribution of X bar. Sampling distribution of X bar. Okay. Of X bars. Okay. So I have to pull out the information for X bar and Sx. So my X bar is equal to 2.025. My S is same as Sx is equal to 0.1783 and N is 10. My T alpha by 2 we just found out is 1.833. So our confidence, 90% confidence interval is confidence interval X bar. X bar is 2.025 plus minus 1.833 times S is 0.1783 divided by square root of N is 10. Okay, so let's do this part. By the way, this whole thing, T alpha by 2 multiplied by S divided by square root of N is called margin of error. Margin of error, which is equal to T alpha by 2 multiplied by S divided by square root of N. So if I create some more space, so this is then equal to 2.025 plus minus. We have to calculate this, so we do 1.833 times 0.1783 divided by second x square is square root 10. And that is equal to 0.1034, you might say. So 90% confidence interval. Interval is, the lower boundary is 2.025 minus 0.1034, and the upper boundary is 2.025 plus 0.1034. So this becomes equal to 2.025 minus 0.1034, which is 1.92, let's say. And the upper boundary is 2.025 plus 0.1034, which is 2.128. If you want to round it up, you can say 2.13. So with 90% confidence, we can state that the actual population mean will fall between 1.92 and 2.13. Okay, so if I create some more space, so if I go back to the original problem, the researcher believes that the mean weight of the bats is different from 1.9 grams. Is different from 1.9 grams. Okay, and our 90% confidence interval starts from the 94. We can write the 90% confidence interval. Confidence interval starts from 1.92 at the lower end, at the lower boundary. Thus, the 90% in confidence interval does not contain 1.9. Hence, at 10% level of significance, we can support the researchers' claim that the mean weight of these bats is different from 1.9. Why? Because the 90% confidence interval does not contain 1.9. 1.9 is to the left of 1.92. The lower boundary is 1.92, upper boundary is 2.13. 1.9 is below 1.92 and it does not fall in the 90% confidence interval. Therefore, at 10% level of significance, we can support the researchers' claim that the mean weight of these bats is different from 1.9. Now, this is the long way of doing it. There is a shorter way if you have the calculator. to calculate. So the next one is, let me change the color of the ink also. Calculate 90% confidence interval of the mean interval for the mean weight using TI-84. We have already entered the sample data in L1. Okay, so next thing we press is Start button. So press Start button. Then highlight Test. Then we will scroll down to T interval. The reason we are using T interval, because we do not know the population standard deviation. So we scroll down to T interval, which is number 8 in my calculator, and hit enter. Okay, and in the T interval, input, INPT is input, should be data. Okay, list is L1. If you don't have L1, you can get it by pressing the second key and then number 1. Okay. That will get you L1. Frequency is 1 because you have entered each data point only once, and sea level is 0.9. Change it to 0.9 if it is something else. Okay, and then you go calculate. Hit enter. And you get the 90% confidence interval as 1.92, comma 2.13. Is it about the same as what we got before? Let's check on that. Yep. So with 90% confidence, we can state that the actual population mean will fall between 1.92 and 2.13. This confidence interval does not contain y, does not contain 1.9. Create some space. Hence, we can support the researchers' claim. Researchers claim that the mean weight is different from 1.9 at 10% level of significance. Level of significance, which is same as or 90% level of confidence. So I'll stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I appreciate that. If you like this video, please share this with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time.